Hello dear students, in this video I will continue with Unit 5 probability, coming to the last topic of this unit, which is Bayes theorem. In this video I will discuss about this Bayes theorem and solve the questions from exercise 12.8 of CBSE class 11 applied mathematics by M. L. Aggarwal. First we will see what is this Bayes theorem. So this is the statement of the theorem. If A1, A2 up to etc. An are n non-empty events which constitute a partition of a sample space S. Now this partition of a sample space is nothing but these events are mutually exclusive and exhaustive. That is A intersection Aj equal to 5 for all I comma j, I not equal to j. That is A1, A2 are pairwise disjoint and A1 union A2 union up to etc. union An. This is equal to the sample space S. If B is any event of non-zero probability, then we have probability of Ai given B. It is equal to probability of Ai into probability of B given Ai upon summation j is equal to 1 to n, probability of Aj into probability of B given Aj for any I equal to 1, 2, 3 up to etc. n. So this is basically Bayes theorem. So Bayes theorem states that if A1, A2 up to etc. An are mutually exclusive and exhaustive events of a sample space S, and if B is any event, we have probability of Ai given B as probability of Ai into probability of B given Ai upon summation probability of Aj into probability of B given Aj. So this is Bayes theorem. Let us prove this. So we know by conditional probability, using conditional probability we can write probability of Ai given B as probability of B intersection Ai upon probability of B. That is probability of Ai given B, it is equal to probability of B intersection Ai upon, now probability of B we can write using the theorem of total probability or the law of total probability as summation j equal to 1 to n probability of Aj into probability of B given Aj. So this is by theorem of total probability. In my previous video I have explained about this, that is the theorem of total probability. So using that theorem we can write probability of B as summation j equal to 1 to n probability of Aj into probability of B given Aj. Now this is equal to, now this probability of B intersection Aj we can write it as probability of Ai into probability of B given Ai. This is by the multiplication rule of probability. This is by multiplication theorem on probability. So we have probability of Ai given B, it is probability of Ai into probability of B given Ai upon summation probability of Aj into probability of B given Aj. So this is Bayes theorem. How this theorem will be applied, we will understand from the solution of the exercise questions. Moving on to the exercise question. From exercise 12.8, the first question. Bag 1 contains 3 red and 4 black balls, while another bag 2 contains 5 red and 6 black balls. One ball is drawn at random from one of the bags and it is found to be red. Find the probability that it was drawn from bag 2. So here we have 2 bags, 1 and 2. One has 3 red and 4 black balls, and bag 2 has 5 red and 6 black balls. Now one of the bags is selected at random and a ball is drawn. It was found to be red. We need to find the probability that it was drawn from bag 2. So here if the outcome is given and if we are asked how we got this outcome, then we have to apply Bayes theorem. On the other hand, if we are asked to find the probability of a particular outcome, then we have to apply law of total probability or the theorem of total probability. So here let us take, let E1 and E2 be the events, bag 1 and bag 2 are chosen respectively, and let us take, let A be the event which is getting a red ball. So probability of E1 is half and probability of E2 is also half. And we have taken, let A be the event which is getting a red ball. So we need to find the probability that it was drawn from bag 2. So we need to find probability of E2 given A. So this is what we have to find. Now using Bayes theorem we can find this probability. So before that let us find probability of A given E1. Probability of A given E1 is drawing a red ball from the first bag. So it is 3 by 7. And probability of A given E2 is drawing a red ball from the second bag. It is 5 by 11. Therefore, probability of E2 given A, it is equal to probability of E2 into probability of A given E2 upon summation I is equal to 1 to 2 probability of EI into probability of A given EI. Now this is nothing but it is probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. So this is equal to half into 5 by 11 upon half into 3 by 7 plus half into 5 by 11. So this is equal to half into 5 by 11 upon half is common, we can take it outside, and let us take LCM for the remaining. 3 by 7 plus 5 by 11, so it is 33 plus 35 by 77. So this half and this half will go. So this is equal to 5 by 11 upon 68 by 77. So this is 35 by 68. Therefore, probability of E2 given A is 35 by 68. So this is the required probability. Moving on to the next question. Suppose 5% of men and 0.25% of women have grey hairs. A grey haired person is selected at random. What is the probability of this person being male? Assume that there are equal number of males and females. So here it is given 5% of men and 0.25% of women have grey hairs, and a person selected at random is found to have grey hair. We need to find the probability that this person is a male. So let us take, let E1 and E2 be the events selecting a male and female respectively. Since here there are equal number of males and females, it is given. So probability of E1 is half and probability of E2 is half. And let us take, let A be the event selecting a grey-haired person. We need to find the probability that this person is a male. So we need to find probability of E1 given A. So for that we need probability of A given E1. Probability of A given E1 is 5%. It is given 5% of men have grey hairs. We have taken A as the event selecting a grey haired person. So probability of A given it is a male is 0.05. And probability of A given E2 it is 0.25%. So it is 0.0025. Now probability of E1 given A using Bayes theorem. Probability of E1 given A, it is equal to probability of E1 into probability of A given E1 upon probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. So this is equal to half into 0.05 upon half into 0.05 plus half into 0.0025. So the half will cancel out. So we have 0.05 upon 0.0525. Or this is 500 upon 525. So if we divide it by 25, we get 20 upon 21. Therefore, probability of E1 given A, it is equal to 20 by 21. Next question. It is known that 60% of students in a college reside in hostel, while remaining 40% are day scholars. 30% of all students who reside in hostel attain A grade and 20% of day scholars attain A grade. If one randomly chosen student has A grade, then what is the probability that he lives in the hostel? So here it is given 60% of students are hostelers and 40% are day scholars. And 30% of hostelers get A grade and 20% of day scholars get A grade. And one randomly chosen student has A grade. We need to find the probability that he lives in the hostel. So let us take, let E1 and E2 be the events selecting a hosteler and a day scholar respectively. Let E be the event selecting a student who got A grade. So here probability of E1 will be, it is given 60% of students reside in hostel. So probability of E1 is 0.6 and probability of E2 is 0.4 since 40% are day scholars. Then probability of E given E1. It is given 30% of students who reside in hostel get A grade. So we have taken E as the event selecting a student who got A grade. So probability of E given A1 will be 30%, 0.3. Then probability of E given E2 is, there is a probability that the student got A grade given the student is a day scholar. It is 20%, is 0.2. Now we need to find probability that he lives in hostel. So we need to find probability of E1 given E. So probability of E1 given E, it is equal to probability of E1 into probability of E given E1 upon summation I is equal to 1 to 2 probability of EI into probability of E given EI. So this is very easy. We just have to substitute the values. So it is 0.6 into 0.3 upon 0.6 into 0.3 plus 0.4 into 0.2. So it is 0.18 upon 0.18 plus 0.08. 0.18 upon 0.26. This is 18 by 26, or it is 9 by 13. So probability of E1 given E, it is equal to 9 by 13. Next question, a factory has two machines A and B. Past records show that machine A produced 60% of the items of output and machine B produced 40% of the items. Further, 2% of the items produced by machine A and 1% produced by machine B were defective. All items are put into one stockpile and then one item is chosen at random from this and is found to be defective. What is the probability that it was produced by machine B? So here we have the machine A produce 60% of items and B produce 40% of items, and 2% of items produced by machine A is defective and 1% produced by machine B is defective. And it is given one item chosen at random is found to be defective. We need to find the probability that it was produced by machine B. So let us take, let E1 and E2 be the event selecting machine A and B respectively, and let E be the event selecting a defective item. So we need to find probability of E2 given E. So the item which is chosen was found to be defective. We need to find the probability that it was produced by machine B. We have taken E2 as selecting machine B. So probability of E1 is 0.6, selecting a product of, and probability of E2 is 0.4. So let us take E1 and E2 are the events selecting a product of machine A and B respectively. Now probability of E given E1, it is equal to, here it is given 2% of items produced by machine A is defective. So this is 0.02, and probability of E given E2, it is 0.01. Now we need to find probability of E2 given E. By Bayes theorem, probability of E2 given E, it is equal to probability of E2 into probability of E given E2 upon summation I equal to 1 to n probability of EI into probability of E given 1 to 2. Here only two events are there. E given EI. So this is equal to 0.4 into 0.01 upon 0.6 into 0.02 plus 0.4 into 0.01. So this is equal to 0.004 upon 0.012 plus 0.004. So this, when we simplify, we will get the answer 0.016. So this is 4 by 16, which is 1 by 4. So the required probability is 1 by 4. Next question, in a class having 60% boys, 5% of boys and 10% of girls have an IQ of more than 150. The student is selected at random and found to have an IQ of more than 150. Find the probability that the selected student is a boy. Again, this is also a very easy question. So let us take, let E1 and E2 be the events selecting a boy and a girl respectively, and let A be the event selecting a student with IQ more than 150. So here a class has got 60% boys. So probability of E1 will be 0.6 and probability of E2 is selecting a girl. Remaining 40% are girls. So probability of E2 is 0.4. and probability of A given E1. So A is the event selecting a student with IQ more than 150. So probability of student more than 150 given the student is a boy, it is 5%. So this is 0.05 and probability of A given E2. It is selecting a student with IQ more than 150 given the student is a girl. It is 10%, which is 0.1. Now we need to find the probability that the selected student is a boy. So we need to find probability of E1 given A. So it is probability of E1 into probability of A given E1 upon summation I is equal to 1 to 2 probability of EI into probability of A given EI. So this is equal to 0.6 into 0.05 upon 0.6 into 0.05 plus 0.4 into 0.1. So it is 0.6 into 0.05 upon 0.6 into 0.05 plus 0.4 into 0.1. So this is equal to 0.030 upon 0.030 plus 0.04. So it is 0.03 upon 0.07, which is 3 by 7. Therefore, probability of E1 given A, it is equal to 3 by 7. Next question. A man is known to speak the truth 3 times out of 5 times. He throws a die and reports that it is a number greater than 4. Find the probability that it is actually a number greater than 4. So here it is given a man speaks truth for 3 out of 5 times. He throws a die and he says it is a number greater than 4. We need to find the probability that it is actually a number greater than 4. So this is the outcome and this is what has happened before. So we have to take, let E1 be the event, number on the die is more than 4, and E2 be the event, number on the die is less than or equal to 4. And let A be the event, the man reports the number is more than 4. So probability of E1 will be, now getting a number more than 4 will be, the outcomes favorable to E1 are 5 and 6. So probability of E1 will be 2 by 6. And probability of E2, this is 1 by 3. Probability of E2 will be 4 by 6, which is 2 by 3. Then probability of A given E1. So A is the event, the man reports more than 4. Probability of A given E1 is the man reports 4 and the die is also more than 4. It means the man has spoken the truth. So probability of A given E1 is 3 by 5. And probability of A given E2 is the man reports 4 but the number on the die is less than or equal to 4. It means the man has spoken a lie. So the probability will be 1 minus 3 by 5, which is 2 by 5. Now we need to find probability of E1 given A. So by Bayes theorem, probability of E1 given A, it is equal to probability of E1 into probability of A given E1 upon summation I is equal to 1 to 2 probability of EI into probability of A given EI. So this is equal to 1 by 3 into 3 by 5 upon 1 by 3 into 3 by 5 plus 2 by 3 into 2 by 5. So this is equal to 3 by 15 upon 3 by 15 plus 4 by 15. So this is 3 by 15 upon 7 by 15. So 15 will cancel. This is equal to 3 by 7. Therefore, probability of E1 given A, it is equal to 3 by 7. Coming to this 7th question, earn 1 has 2 white and 3 black balls. Earn 2 has 4 white and 1 black ball. And earn 3 has 3 white and 4 black balls. And earn is selected at random and a ball is drawn at random. What is the probability of drawing a white ball? If the ball drawn is white, then what is the probability that earn 1 was selected? So we have 3 earns, earn 1, earn 2, earn 3. Earn 1 has 2 white and 3 black balls. Earn 2 has 4 white and 1 black ball. Earn 3 has 3 white and 4 black balls. And earn is selected at random and a ball is drawn. We need to find the probability of drawing a white ball. And then here this is the theorem of total probability or law of total probability. Whereas the second subdivision, if the ball drawn is white, what is the probability that earn 1 was selected? So here the outcome is given. We need to go back to check from which earn it was taken. So the second subdivision is using Bayes theorem. So if the ball drawn is white, we need to find the probability that earn 1 was selected. So let us take, let E1, E2 and E3 be the events, selecting earn 1, earn 2 and earn 3 respectively. And let A be the event drawing a white ball. So we have any one of the earns can be chosen. There are 3 earns. So probability of E1 is 1 by 3. Probability of E2 is also 1 by 3. And probability of E3 is 1 by 3. Since here it is given, an earn is selected at random. So all the selection of each earn has got equal probability. And then let us take, let A be the event drawing a white ball. So probability of A given E1 is drawing a white ball given it is from earn 1. So probability of A given E1, it is equal to 2 by 5. Then probability of A given E2. So it is drawing a white ball given it is from earn 2. So probability of A given E2 will be 4 by 5. And probability of A given E3, it is 3 by 7. And now coming to the first subdivision, probability of drawing a white ball. So for the first subdivision, we need to find probability of A. So by law of total probability, probability of A, it is equal to probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2 plus probability of E3 into probability of A given E3. So this is equal to 1 by 3 into 2 by 5 plus 1 by 3 into 4 by 5 plus 1 by 3 into 3 by 7. Let me continue here. Probability of A is equal to 1 by 3 is common. It can be taken outside. The LCM is 35. So here we have 14 plus 28 plus 15. So this is 1 by 3 into this. When we simplify, we get it as 57 upon 35. So this is equal to 19 by 35. Therefore, probability of A equal to 19 by 35. Now the second subdivision. The second subdivision, if the ball drawn is white, then what is the probability that urn 1 was selected? So we need to find probability of E1 given A. So this is what we have to find. So using Bayes theorem, probability of E1 given A equal to probability of E1 into probability of A given E1 upon summation probability of EI into probability of A given EI. I is equal to 1 to 3. Now this summation is nothing but it is probability of A. So probability of A we have already calculated, so that we can substitute here. And in the numerator we have probability of E1 into probability of A given E1 upon 19 by 35. So this is equal to 2 by 3 into 7 by 19, or it is equal to 14 by 57. Therefore, probability of E1 given A, it is equal to 14 upon 57. So this is the answer for the first subdivision, probability of drawing a white ball, and this is the answer for the second subdivision. If the ball drawn is white, the probability that urn 1 was selected. Next question. Bag 1 contains 5 red and 4 white balls, and a bag 2 contains 3 red and 3 white balls. 2 balls are transferred from bag 1 to bag 2, and then 1 ball is drawn from bag 2. If the ball drawn from bag 2 is red, then find the probability that 1 red ball and 1 white ball are transferred from bag 1 to bag 2. So here we have bag 1 consists of 5 red and 4 white balls. Bag 2 consists of 3 red and 3 white balls. 2 balls are transferred from bag 1 to bag 2, and then 1 ball is drawn from bag 2. If the ball drawn from bag 2 is red, we need to find the probability that 1 red ball and 1 white ball are transferred from first bag to the second bag. Let us take let E1 be the event drawing 2 red balls from bag 1. So if we draw 2 red balls from bag 1, then those 2 red balls will be transferred to bag 2. So if E1 occurs, then the second bag will have 5 red balls and 3 white balls. And let E2 be the event drawing 2 white balls from bag 2. And if E2 occurs, then the second bag will have 3 red and 5 white balls, because 2 white balls will be transferred to bag 2. Let E3 be the event drawing 1 red and 1 white ball from bag 1. So if E3 occurs, then the second bag will have 4 red and 4 white balls. So this is what happens to bag 2 if each of these events occur. Let us take let A be the event drawing a red ball. So we need to find probability of E3 given A. So first let us find each of these probabilities. Probability of E1 is drawing 2 red balls from bag 1. So drawing 2 red balls from bag 1, 2 red balls can be drawn from 5 red balls in 5 C2 ways, and the total number of outcomes is 9 C2. So this is equal to 5 into 4 upon 9 into 8. This is 5 by 18. Then probability of E2 is the event drawing 2 white balls from bag 1. So 2 white balls can be drawn from 4 white balls in 4 C2 ways upon 9 C2. So this is 4 into 3 upon 9 into 8. This is 3 by 18. Then probability of E3 is the even drawing one red and one white ball from bag 1. So one red ball can be drawn from 5 red balls in 5 C1 ways, and one white ball can be drawn from 4 white ball in 4 C1 ways upon 9 C2. So this is 5 into 4 upon 9 into 8 by 2. So this is 10 by 18. Let us keep the denominator common so that it is easy to simplify. Now probability of A given E1. So A is the even drawing a red ball. Probability of drawing a red ball given E1 has occurred is drawing a red ball from 5 red and 3 white balls. So probability of A given E1 is 5 by 8. Then probability of A given E2. It is drawing a red ball given E2 has occurred. So it is drawing a red ball from 3 red and 5 white balls. So it is 3 by 8. Then probability of A given E3. It is drawing a red ball given E3 has occurred. So it is 4 by 8. Now by Bayes theorem, we need to find probability of E3 given A. This is what we have to find. So we can use Bayes theorem to find this probability. Probability of E3 given A. It is equal to probability of E3 into probability of A given E3 upon summation I is equal to 1 to n probability of EI into probability of A given EI. So this is equal to probability of E3 is 10 by 18 into probability of A given E3 is 4 by 8 upon probability of E1 into probability of A given E1. 5 by 18 into 5 by 8 plus probability of E2 into probability of A given E2, 3 by 18 into 3 by 8 plus probability of E3 into probability of A given E3, 10 by 18 into 4 by 8. So here this is 40 upon 18 into 8, whole thing divided by 25 plus 9 plus 40 upon 18 into 8. So these two will get cancelled. Here we have 40 upon 74, or it is 20 by 37. Therefore, probability of E3 given A equal to 20 by 37.